Hello viewers, I believe it's a bright day for every one of us. Today is about evaluating limits, a very simple concept, talking about the very first topic when you are discussing the introductory calculus. So we'll be looking at these questions and see how to evaluate limits. Right, so we have question 1 which says evaluate the following. And what are we evaluating? This is read as limit as x tends to 2. Tend. And then since it's a plural form, tends. So limit as x tends to 2, 7 minus 4x plus 8x squared minus x cubed. So what does x tends to 2? What does it mean? You either say tend or approach. You either say tend or approach. So you either say limit as x tends to 2 or limit as x approaches 2 for this particular function. So we want to evaluate, see when x is approaching 2, what will this function, what will it be approaching? X is approaching 2, what will this one be approaching? And the second one, limit as x tends to 0, is saying that when x is approaching 0, moving towards 0, what will this function, what will it be approaching? That is the concept or the basic idea behind limit. Okay, so we have number 1a. We're just going to write down the question as it is. So we have limit as x approaches 2 for 7 minus 4x plus 8x squared minus x to the third power. Alright, there isn't much to do here. All we need to do is that wherever we see x in this function, we're just going to be replacing it with 2. So that's what the idea of limit as x approaches 2 is all about. So it means that we are going to be having 7 minus 4 multiplying 2, that's in the place of x, plus 8 multiplying 2 squared in the place of x squared, and then minus 2 cubed. So that's going to be 7 minus 4 multiplied by 2 is 8, plus 2 raised to power 2 is 4, and 4 times 8 is going to be 32. So that's plus 32, and then minus 2 cubed. 2 cubed is equals to 8. So what are we having in that situation? 7 minus 8 is negative 1. Negative 1 plus 32 is negative 31. Sorry, negative 1 plus 32 is 31. And 31 minus 8 is going to give us 23. So the limit as x approaches 2 for this particular function is equals to what? 23. And how is it read? It means that when you want to limit this function as x is approaching 2, it means that the whole of this function will be approaching 23. As x is approaching 2, the whole of this function will be approaching what? 23. That's that for number 1. Letter B, we're evaluating the limit. What will this function be approaching when x is tending towards 0? When x is approaching 0, what will this one be approaching? You can see that it is the same function that I repeat here. I did that intentionally. So this is approaching 0, is tending towards 0. So what will this be tending to? And as before, what we need to do, anytime we are evaluating limit, all we just need to do is what? To just substitute directly. Okay, and that's going to be 7 minus 4 multiplying 0 plus 8 multiplying 0 squared, and then minus 0 cubed. That becomes 7. 4 multiplied by 0 is 0, plus 0 squared is still 0. 8 multiplied by 0 is 0, minus 0 cubed is still 0. So eventually we'll be having what? 7 as our solution. It means that as x is tending towards 0, as x is approaching 0, this limit will be approaching 7. That's that. Now to letter C. Limit as x tends to 0 for x squared plus 5x plus 9 over 2x squared minus 3x plus 15. And as before, like the first two, all we need to do is to just substitute 0 wherever we see x in this particular function. So this limit becomes, we are going to be having 0 squared plus 5 multiplying 0 and then plus 9. All together, that's wherever we see x equals 0. In the place of 2x squared, we'll be having 2 multiplying 0 squared, and then minus 3 multiplying 0, and then plus 15. Okay, so 0 squared is going to be 0. That implies 0, and then plus 5 multiplied by 0 is also 0, and then plus 9 as we have it, over 2 multiplied by 0 squared, that's still going to be 0, minus 3 multiplied by 0, that's also 0, and then plus 15. So eventually 0 plus 0 plus 9, that's going to be 9, and then 0 minus 0, 0 plus 15 is also going to be what? 15. And of course, we have been taught in our lower primary and even upper primary school that when you have fractions like this, it can be simplified further. So they have something in common. 9 divided by 9 over 15, they have 3 in common. So 3 in 9 is going to be 3, and 3 in 15 is going to be what? 5. So we have 3 over 5. That's A, that's B, and that's C for you. So we'll be moving on to D and E. Alright, so I decided to give you a little interlude before we move on to letter D and letter E, before we evaluate those limits. And what is the interlude about? Okay, probably back in your secondary school, of course this is still a secondary school concept in under further mathematics. Maybe in your lower primary school, upper primary school I mean, or junior secondary school, you may have been playing or just doing some things on the calculator, and you come across concepts like this. Maybe you say 3 divided by 0, or let me put it this way, 3 divided by 0, and the calculator is just going to give you an answer. And what is the answer the calculator is going to give you? It's going to give you math error. Right, the calculator is right to have given you math error. When you see questions or concepts like this on calculator, there are reasons for that. So you could have done something like this, you have a math error, or you are working on something, probably even something like this, tan 90 degrees, you press that into your calculator, the response you are going to have also is also what? Math error. Now there are reasons for this. So what are the reasons for having what? Math error. You are telling computer that it should give you a number that is so big than itself that it cannot compute. It is so big, bigger than itself that it cannot compute. And when it comes across that kind of concept, it's going to give you what? Error. Even when it seems like seemingly sophisticated or calculators, like the one we call, is it the textbook, what is it called, natural display, of course. When you enter stuff like this, maybe 9, 9, 9, 9, 9, let's say you are able to enter 9 up till 15 times on the screen, or you complete everything, and then you still multiply this same by 9, 9, 9, 9, 9 again to fill up what? Fill up the screen. You first of all wrote down 9, 9, 9, 9 and press equal to, and then you now multiply that result by 9, filling up the screen again. There's a possibility of the calculator giving you what? Math error also. Now, what is the reason for that? The calculator is telling you that this number you are entering into me, they are too big for me to what? To comprehend. They are too big for me to compute. So when a calculator comes into that kind of concept, it's going to what? Tell you that I give up. And in telling you that I give up, it gives you what they call what? Math error. Now, but moving on, when you get to a higher level in mathematics, when you come across concepts like this, like 3 divided by 0, or 3 over 0, what we use to represent that, instead of we mathematicians writing math error, what we write is what? Infinity. And what is infinity? Infinity is what? Is a very large number. A very large number that cannot be estimated. A very large number that cannot be estimated. Of course, we have numbers in countings of tens, countings of hundreds, countings of 1,000, 10,000s, hundreds of thousands, million. After million, we have billion. After billion, we have trillion. After trillion, we have quadrillion. We have quintillion. We have sextillion. We have septillion, and so on and so forth. Please don't mention zillion for me, because I've had weird things from so many students telling me zillion, and I asked them how many zeros does zillion have. None of them have been able to tell me. But after billion, we have trillion, we have quadrillion, we have quintillion, we have sextillion, we have septillion, we have octillion, we have nonillion, and so on and so forth. Decillion. Alright, I don't know the end myself. Maybe when I go for more research, you can do that yourself. So when you have 3 over 0, it gives you what? Infinity. Infinity is what? Is a very large number that cannot be what? Estimated. Also, when you have 1 over 0, 1 over 0 still this gives you what? The same what? Infinity. When you have 2,593 still over 0, as long as it is over 0, it will always be equals to what? Infinity. That's what it tells you. Now, by the rule of mathematics, of course, everybody knows that when you have 18 divided by 3, 18 divided by 3 is going to be equal to what? 6. And by implication, 18 divided by 6 also is going to be equal to what? 0 or equals to 3. 18 divided by 3 is equals to 6. That implies that 18 divided by 6 also will be going to be equals to what? 0. And we're going to be applying that concept in here. So if we say 3 divided by 0 is equals to infinity, so what's going to be 3 divided by infinity? When a number is dividing infinity, well, that's a very large number. What is it going to be equals to? It's going to be equals to 0. Also, if you have 2,593 divided by infinity, it's also going to be equals to what? 0. If you have 1 over infinity, 1 over infinity is also going to be equals to what? 0. So by intuitively, we should also always know that whenever we are dividing a number by 0, the result is going to be what? Infinity. And anytime you are dividing any number by what? Infinity, as we have it like this, the result is also going to be what? 0. So that's a little interlude I have for us before we proceed on to this letter D. So we have limit as x tends to infinity. The concept of infinity has been explained. Limit as x tends to infinity for this function x squared plus 3x plus 2 and then over x squared minus 2x plus 7. Now I told you when you're evaluating, especially this first 3, what we needed to do was to just plug in our value into the function that we're given, and then we evaluate the limit. But when it comes to infinity, we don't just plug in directly. There are little things that we need to do first of all before we plug in the value of infinity into the functions that we are given. Now what is it that we always do anytime we want to evaluate infinity? This is a fraction, and every fraction has what? Numerator and also what? Denominator. So we come to the denominator. In the denominator, which x has the highest power? The x with the highest power in the denominator, that is what we are going to make use of. So what is the x with the highest power in this concept? The x with the highest power is this one, and it's carrying what? X squared. So what are we going to do with this x squared? We are going to divide every aspect of this numerator and every term in this what? Every term in the numerator by x squared, and we are going to divide every term of the denominator also by what? X squared. So what does this limit become? So it means that this limit becomes limit as x tends to infinity. So we have x squared here. So it's going to be, for the numerator first of all, x squared over x squared by this, then plus 3x also over this same x squared, and then plus 2 over this same x squared. So what does that become? That's going to be what? Over. As we have this now, this is going to be what? Also x squared over the same x squared, then minus 2x over same x squared, which is the highest power in the denominator, and then plus 7 over that same what? X squared. So when we simplify this, what does it become? That becomes limit as x tends to infinity. Now we have x squared divided by x squared. When we have x squared divided by x squared, that's going to be 1 plus 3x over x squared. This x would have cancelled one of these, so we'll be left with 3 over x. And of course, nothing to cancel for this, so that's still going to be what? 2 over x squared. Okay, over x squared over x squared is also going to be what? 1. Then minus 2x over x squared, that's going to be 2 over x. And then finally plus 7 over x squared. So when we get to this point, having done this, it is from here now that we can now substitute our infinity. And when we have our infinity substituted, that becomes 1 plus 3 over infinity. Remember, infinity is a very large number that cannot be estimated. And then plus 2 over infinity squared. So altogether over 1 minus 2 over infinity plus 7 over infinity squared. So what does that become? We're having what? 1 here, and then plus. Then from our interlude, we know that when a number is being divided by 0, that number becomes infinity. And by intuition, when you divide the same number by infinity, so the result we are going to have is going to be what? 0. So 3 over infinity is also going to be equal to what? 0. And then plus. The next one. Infinity is already a large number, and you have a large number. You now square the large number again. What happens? It means that it explodes the more. It explodes what? The more. That it has gone beyond already gone beyond quantification, you are now multiplying it by itself again. So what happens? It still becomes infinity. So still 2 over infinity, that's going to be equal to what? 0. Alright, here we now have 1 as in denominator, then minus 2 over infinity is also 0, and plus 7 over infinity squared, like we had it in this case, so that's also going to be what? 0. So eventually, what is our solution? 1 over 1, which of course is equal to what? 1. So when we limit this function, x tends to infinity for this particular function, the result is going to be equal to 1. Letter E. Limit as x tends to infinity. As before, we proceed like we did in letter D. So what do? Limit as x tends to infinity. Identify the highest power in the denominator. The highest power in the denominator is x raised to power 4. We are going to divide the denominator by this same x raised to power 4 and the numerator by the same what? X raised to power 4. But please take note of something. Okay, because I choose to arrange my own here like this does not mean that the highest power in the denominator will always be the first term. No, it doesn't mean that. It doesn't mean that. For example, I can give you something like this: 7x plus 2x to the third power over, let's say, 8 plus 2x minus 3x to the fifth power, and then plus 9x squared. Now, if you look at this now, in this case, this one is not even carrying any term in any coefficient of x. And this is not the highest power of x. This is the highest power of x, and it so happens to be around the middle term. This is not the highest power of x. So when you want to divide by the numerator and the denominator, what are you going to divide by? You are not going to divide by 8, but you are going to divide by what? X raised to power 5. You are dividing by x raised to power 5 because that is the denominator that's carrying the highest power of x. So please take note of that in case you are working on any question of your own. Please take note. Alright, so we have this limit, and that's going to be 7x to the third power over x raised to power 4, and then plus 8x still over x raised to power 4 minus 5 over x raised to power 4. So all together over x to the fourth power over x to the fourth power minus 18x squared over x to the fourth power minus 4x over x raised to power 4, and then plus 13 over what? X raised to power 4. So it is the simplification that we need now, and that's going to be the limit as x tends towards infinity for which particular one? X raised to power 3 over x raised to power 4. This 3 would have cancelled 3 out of this, so we left with only 7 over x, and then plus 8 over x cubed minus 5 over x to the fourth power. So all together over x raised to power 4 divided by x raised to power 4, of course that is also equals to 1, minus 18x squared divided by 4 x raised to power 4, that's going to be 18 over x squared. These would have cancelled 2 of this, and then minus 4 over x to the third power, and then extending that plus 13 over x raised to power 4. So it is from here now we can now substitute our infinity. I haven't done the simplification. So that becomes 7 over infinity plus 8 over infinity cubed minus 5 over infinity raised to power 4. So all together over 1 minus 18 over infinity squared minus 4 over infinity cubed, and then plus 13 over infinity to power 4. So what happens in that situation? 7 over infinity, of course, that becomes 0, plus 8 over infinity cube also equals to 0, and then minus 5 over infinity to the fourth power is also equals to 0. So all the numerators find themselves to be what? 0. And then under we have 1 standing alone, and then minus 18 over infinity squared, that's going to be 0 also, minus 4 over infinity cubed, that's also going to be equals to 0, and then 13 over infinity to the fourth power, that's going to be plus 0. So eventually what are we having? 0 plus 0 minus 0, that's still what? 0, over 1 minus 0 minus 0 plus 0, that's equals to what? 1. So what is 0 divided by 1? That is equals to 1. So the solution is equals to 1. Very simple and straightforward. Thank you. So ladies and gentlemen, I give you evaluation of limit from Introductory Calculus. Enjoy yourself. Peace out.